Find the distance between these pair of points. You have 3, -5 and -3, 0. Well, that requires the distance formula. Let's write it out. The distance formula is d equals huge square root of x sub 2 minus x sub 1, close it, square it, plus y sub 2 minus y sub 1, close it, square it. Now, what's x sub 2, what's y sub 1, and blah, 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 blah. Pick any of your points and call it x sub 1, y sub 1. Pick any of your points and call it x sub 2, y sub 2. Then we just kind of plug stuff in. Okay, so the distance is going to equal the big square root of x sub 2, which I labeled -3, minus x sub 1, which I labeled regular 3, squared, plus y sub 2, which I labeled 0, minus y sub 1, which I labeled -5, so double negative. I'll clean that up in a minute. And now it's just a matter of gross Pythagorean theorem looking stuff. Okay, -3 minus 3 is -6 squared. Double negative becomes a positive, so you become plus 5 squared. That's going to equal -6 times itself is 36, plus 5 times itself is 25. And when you add those guys up together, you get the square root of 61. Now, since this chapter focuses on dealing with square roots, or since I guess this unit focuses on square roots, I would look at this and see if there's anything you can do to change it, and the answer is no. Now, anybody can run to a calculator and try to find out that the square root of 61 is going to be like 7 point something, but I'm not worried about that. I'm going to think, all right, well, can I make a factor tree out of 61? No, 61 doesn't turn into anything, so I'm going to leave it like that because this is the square root section. So we're going to leave it like that. So that's my answer.